Hello guys, welcome back to the virtual lab session. In the last video, we have seen that our aim was to predetermine the voltage regulation using open and short circuit by EMF method. And we have seen the open circuit test, how it is constructed and what will happen. And now we are going to see the short circuit test. Now drag this experiment to the workspace. And you can see a circuit diagram which is similar to the open circuit test, and the abbreviation and the rating of a DC shunt motor and the alternator are all same, but in circuit diagram there are some difference between the open circuit test and the short circuit test. And now let us see what it is. You can see the circuit diagram. Several components are connected, in which one end of the DC shunt motor is connected to the 440 volt DC power supply through rheostat and DPST switch, and the other end of the DC shunt motor is coupled to the rotor of an alternator, and above the field excitator system is connected to a separately 220 volt DC power supply through rheostat and DPST switch, which is connected to the alternator through slip rings. And the output of an armature are short circuited, where in open circuit test you have seen it is open circuited where no current is flown. Here the current flown will be measured by this experiment. And now let us see the procedure how it works. Close the DPST switch of the DC shunt motor connecting in the winding of a DC shunt motor, and by varying the rheostat you can increase or decrease the speed of an alternator through that is when the current starts to flow into the DC shunt motor, the armature starts to rotate, that is the output will be the mechanical, and which is interconnected to the alternator through shaft, and which starts to rotate and the alternator gains speed. By increasing the rheostat, we can set the alternator to its rated speed, and the alternator rated speed is 1500 rpm, that is given here. We are going to increase the alternator speed. You can see the speedometer reads the alternator speed. We have to set it to 1500 rpm. Now we have set the rated rpm of the alternator. After this, close the DPST switch of the field excitator system, and you can see the field winding current and the voltage are 0, and the output of the alternator is also equal to 0. Now by varying the rheostat you can see some current starts to differ in the armature of the alternator. Like this we are going to take reading to several values until the armature reaches its rated current. After taking some value we have to store it and we have to show the data. Like this we are going to repeat. You know what is the rated speed of the armature current? That is 4.2 ampere. Until that we can take several readings. and we have taken until the armature reaches its rated current. Now show data. You can see the table for which we can plot several graphs, that is the line current and the armature current, the line current and the speed of the alternator, and the input current given to the motor and the output of a motor. Like this we can do several graphs. And what I observed from this experiment is that by from both the experiment, that is short circuit test and the open circuit test, is by varying the field current and the voltage, the output of the armature current and the voltage starts increasing. But in the field current will be some or initially from zero, but the voltage of the armature of an alternator is not at initial position. This is due to some residual magnetism in the field winding of an alternator. And now we have done our part, and before leaving it you have to set all the rheostat back to its position and set or off or close the DPST switch. Thank you.